In this video, we are leaving the triangle behind and graphing just sine functions, not cosine. Sine and cosine both are functions. We can write them as f with an input of x equals sine with an input of x. The input is going to be the degrees, or radians if you're in another trig class, and the output is a range of numbers, usually between -1 and +1. That can change if we start messing with numbers in front of the sine function. Like if we put 2, then the minimum and maximum would be -2 to +2. Aren't there restrictions on the degrees that we put in? So far we've only worked with triangles, and triangle angles are restricted to be above 0 degrees and less than 180. Are trig functions also restricted? No. We can put any angle into a trig function, positive or negative. So what do these really big or really small angles look like? Let's look at, actually I'm going to start with like a 30-degree angle. Would go just up to that line. So there's our 30-degree angle. Now let's look at this angle, 720 degrees. This is a 180-degree angle. This is a 360-degree angle. And anything bigger than that just kind of continues on in that circle. So 720 degrees is the same thing as two 360-degree angles, and therefore we just go around the circle twice. So 720 degrees is essentially the same as 360, which is essentially the same as 0. Talking about degrees, of course. For a negative angle, it just means we start heading in the other direction. So instead of counterclockwise, we go clockwise. We always start on the positive x-axis and then move our angle from there. So -270 degrees means we'd be moving backwards up to that. -270 degrees is actually the equivalent to a positive 90-degree angle. So again, the angle, this would be a 0, this would be a 90, this would be 180, and positive 270. Right, this is not quite how we're actually going to graph. We're going to have the degrees laid out on the x-axis like so. We're going to graph y equals sine of x. Since it's a video, let's go ahead and skip to the answers. Here's our table of values, and here's what that graph looks like. Notice that the range of this, the height and depth, go all the way up to +1 and all the way down to -1. I also notice that this graph hits the x-axis a few times. This point right here is at 180 degrees, and this point right here is at 360 degrees, looking at our scale. But this is not all. We can actually continue this on. This is the graph of y equals the sine of x, ranging from -360 degrees to 720 degrees. And notice something here. This graph is repeating. If we start at 0, I see that it's going up, and then down some more, and then up, and then it starts repeating. Up, down some more, and then up. So there's a period ranging from 0 to 360 degrees. This ties back to the idea that every 360 degrees, the graph just starts repeating. That 720-degree angle was the same as 360-degree angle and had the same value as just 0. Some things to notice. Like I said, the graph repeats every 360 degrees. The time to complete one full cycle of the graph is called the period if you're measuring in time, and it's called the wavelength if you're measuring in distance. So period and wavelength are very similar. The minimum and maximum value of this particular graph is positive and -1. That's the amplitude of the graph, and the amplitude again can change if we started multiplying the sine function by other numbers, like 2 times the sine of x, 3 times the sine of x. Thank you.